NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math video on the properties of inequalities. Today, we'll learn about the first property of inequalities and understand how it applies when comparing two numbers. Let's start with the first property of inequalities. This property deals with what happens when one number is less than another number. The first rule states that if it is less than b, then it is not equal to b. Let's think about this intuitively. If one number is less than another, they cannot be the same value. This is a fundamental property that helps us understand the relationship between inequality and equality. The second rule states that if a is less than b, then b is greater than a. This rule shows the symmetry of the inequality relationship. It's like looking at the same relationship from two different perspectives. If 2 is less than 5, then 5 is greater than 2. The relationship between the numbers stays the same, but we're describing it from the opposite viewpoint. The third rule states that if it is greater than b, then b is less than a. This is essentially the same as the second rule, but starting from the opposite perspective. Again, it demonstrates the symmetric nature of inequality relationships. Now, let's look at a concrete example to better understand these properties. Let's say we have the numbers 5 and 8. We know that 5 is less than 8, which we write as 5 less than 8. By our first property, this means 5 is not equal to 8, which is certainly true. By our second property, if 5 is less than 8, then 8 is greater than 5. And by our third property, if 8 is greater than 5, then 5 is less than 8, which brings us back to our starting point. Let's summarize what we've learned about the first property of inequalities. First, if it is less than b, then it is not equal to b. Second, if it is less than b, then b is greater than a. Third, if it is greater than b, then b is less than a. These properties help us understand the relationship between numbers and are fundamental to working with inequalities in mathematics. Welcome to this video on the second property of inequalities. Today, we'll learn about the transitive property of inequalities, which is one of the fundamental properties that allows us to work with chains of inequalities. Let's start by understanding the first case of the transitive property. If we have a is less than b and b is less than c, then we can conclude that it is less than c. Let's visualize this on a number line to make it more intuitive. If it is to the left of b on the number line, and b is to the left of c, then it's clear that a must be to the left of c. This gives us the conclusion that a is less than c. Now, let's understand why this property works formally. When we say a is less than b, we mean it is to the left of b on the number line. Similarly, b is less than c means b is to the left of c. So by combining these two facts, we can see that it is to the left of c, which means it is less than c. This is the essence of the transitive property. Now, let's look at the second case of the transitive property. If it is greater than b, and b is greater than c, then it is greater than c. Again, let's visualize this on a number line. If it is to the right of b, and b is to the right of c, then clearly it must be to the right of c. Welcome to this math lesson where we'll explore the third property of inequalities. This property is fundamental to understanding how inequalities work, and we'll see how it's applied in various mathematical contexts. Let's start by understanding what the third property of inequalities is. The third property is also known as the reflexive property, which states that for any real number is less than or equal to a. This is written mathematically as a less than or equal to a. What does this property mean? Simply put, any quantity is always less than or equal to itself. For example, 5 is less than or equal to 5, and -3 is less than or equal to -3. Let's visualize this property on a number line. Consider any point on the number line. According to the reflexive property, it is less than or equal to a, which means that point is to the left of or at the same position as point a. Since a point can't be to the left of itself, it must be exactly at the same position. That's why we use less than or equal to rather than just less than. This property, but it's actually quite important in mathematics. The reflexive property forms the basis of many mathematical proofs and is essential when working with inequalities. For instance, when solving an inequality like x squared minus 4x plus 4 is greater than or equal to 0, we can factor this as x minus 2 squared is greater than or equal to 0. Since any squared term is always greater than or equal to 0, This inequality is always true when x equals 2, which is consistent with our reflexive property. Let's address some common misconceptions about this property. Some students think that the reflexive property uses the strict inequality less than, but it actually uses less than or equal to. The correct mathematical symbol is less than or equal to, which is a sideways, slightly elongated U with a horizontal line underneath it. Welcome to this lesson on the fourth property of inequalities. Today we'll learn about an important concept that helps us determine when two numbers are equal based on inequality relationships. The fourth property of inequality states that if A is less than or equal to B, and B is less than or equal to A, then A must equal B. This makes intuitive sense. If A can't be greater than B, and B can't be greater than A, the only possibility is that they're equal. Let's apply this property to an example. Consider the inequalities. 3x plus 2 is less than or equal to 5, and 5 is less than or equal to 3x plus 2. By the fourth property, we can conclude that 3x plus 2 equals 5. This is now a simple equation that we can solve for x. Now, let's solve this equation. We have 3x plus 2 equals 5. First, let's subtract 2 from both sides. 3x equals 3. Now, we divide both sides by 3. X equals 1. So our solution is x equals 1. Let's verify our solution by substituting x equals 1 back into the original inequalities. For the first inequality, 3 times 1 plus 2 is less than or equal to 5. 3 plus 2 equals 5, which is indeed less than or equal to 5. For the second inequality, 5 is less than or equal to 3 times 1 plus 2. 5 is less than or equal to 5, which is true. Since both inequalities are satisfied, our solution x equals 1 is correct. Welcome to this math lesson on the properties of inequalities. Today we'll be focusing on the fifth property of inequalities, which is a fundamental concept in algebra. The fifth property of inequalities tells us that we can add or subtract the same number from both sides of an inequality, and the inequality sign remains unchanged. Let's see the formal definition of this property. Let's start by examining this property formally. For a strict inequality, we can state, if A is less than B, then A plus C is less than B plus C. This means that adding the same value to both sides preserves the less than relationship. The same applies for the greater than relationship. Similarly for non-strict inequalities. If A is less than or equal to B, then A plus C is less than or equal to B plus C. The same principle applies. Adding or subtracting the same value from both sides preserves the inequality relationship. Now, let's look at the greater than version of this property. If A is greater than B, then A plus C is greater than B plus C. And if A is greater than or equal to B, then A plus C is greater than or equal to B plus C. These principles are fundamental in solving inequalities. Let's see a simple example to apply this property. Example, consider the inequality. 5 is less than 8. We know this is true. Now, let's add 3 to both sides. 5 plus 3 equals 8, and 8 plus 3 equals 11. So we get 8 is less than 11. This new inequality is still true. The less than relationship is preserved. Let's try another example, this time with subtraction. Example, consider the inequality. 10 is greater than 6. Now, let's subtract 4 from both sides. 10 minus 4 equals 6, and 6 minus 4 equals 2. So we get 6 is greater than 2. Again, the greater than relationship is preserved after subtracting the same value from both sides. Now, let's see how this property is applied when solving inequalities. Suppose we want to solve the inequality x plus 3 is less than 7. To isolate x, we need to subtract 3 from both sides of the inequality. Using the fifth property, we can do this while maintaining the inequality sign. After subtracting 3 from both sides, we get x is less than 4. This is our solution. Any value of x less than 4 will satisfy the original inequality. Let's summarize what we've learned about the fifth property of inequalities. First, we can add or subtract the same number from both sides of an inequality without changing the inequality sign. Second, this property works for all types of inequalities, less than, greater than, less than or equal to, and greater than or equal to. Third, this property is essential for solving inequalities by isolating the variable. Remember, when solving inequalities, always apply the same operation to both sides to maintain the balance and keep the inequality true. The sixth property of inequality states that we can add corresponding members of inequalities that go in the same direction. Let's formalize this property. If we have it as less than b and c is less than d, then we can add these inequalities to get a plus c is less than b plus d. This first case shows when both inequalities use the strictly less than symbol. We can also have a mixed case where the first inequality uses less than and the second inequality uses less than or equal to. And finally, we can have a case where both inequalities use less than or equal to. Let's see how this property works visually with a simple example. Let's say we have the inequality is less than b, c is less than d. According to the sixth property, we can add these inequalities. When we add, we get a plus c is less than b plus d. For a specific example, let's use x plus 3 is less than 5 and 2x is less than 7. Adding these inequalities, we get x plus 3 plus 2x is less than 5 plus 7. Simplifying, 3x plus 3 is less than 12. Subtracting 3 from both sides, we get 3x is less than 9. Dividing both sides by 3, we get x is less than 3. Welcome to our video on the seventh property of inequalities. Today, we're going to explore an important rule about the product of two numbers and their signs. Let's begin with our property statement. If a and b are both positive or both negative, then a times b is always positive. And if one is positive and the other is negative, then a times b is always negative. Let's express this property mathematically. First, if both a and b are positive or both are negative, their product is positive. We can write this as for a greater than 0 and b greater than 0, or a less than 0 and b less than 0. This implies that a times b is greater than 0. For the second part, if one variable is positive and the other is negative, their product is negative. We can write this as for a less than 0 and b greater than 0, or a greater than 0 and b less than 0. This implies that a times b is less than 0. Let's visualize this property with some examples. First, let's consider the case where both a and b are positive. For example, if a equals 3 and b equals 4, then a times b equals 12, which is positive. Now, if both a and b are negative, like a equals negative 3 and b equals negative 4, then a times b equals 12, which is also positive. However, if it equals 3 and b equals negative 4, then a times b equals negative 12, which is negative. Or if it equals negative 3 and b equals 4, then a times b equals negative 12, which is also negative. Let's understand this geometrically using the coordinate plane. The coordinate plane is divided into 4 quadrants. In the first quadrant, both x and y are positive, so their product is positive. In the third quadrant, both x and y are negative, so their product is also positive. However, in the second and fourth quadrants, one coordinate is positive and the other is negative, so their product is negative. In summary, the seventh property of inequality states that if a and b have the same sign, both positive or both negative, then their product at times b is positive. If a and b have different signs, one positive and one negative, then their product at times b is negative. This property is fundamental in algebra and helps us determine the sign of a product without actually calculating the value. This is especially useful when working with inequalities and analyzing the behavior of functions. Thank you for watching. Today we're going to learn about the eighth property of inequalities. This important property helps us understand how squaring and other even powers affect inequalities. The eighth property of inequalities states that for any real number x, the square of x is always greater than or equal to 0. In mathematical notation, this is written as x squared is greater than or equal to 0. More generally, we can state that for any real number x, x raised to the power of 2n, where n is a positive integer, is always greater than or equal to 0. This is one of the fundamental properties in mathematics. It tells us that when we square any real number, the result is always non-negative. Let's look at some examples to understand this property better. Example, let's consider the number 3. When we square 3, we get 9, which is indeed greater than 0. So 3 squared equals 9 is greater than or equal to 0. This confirms our property. Example now, let's try with a negative number, negative 3. When we square negative 3, we get 9, which is also greater than 0. So negative 3 squared equals 9 is greater than or equal to 0. This shows that the property works for negative numbers too. Example, let's try with 0. When we square 0, we get 0, which is equal to 0. So 0 squared equals 0 is greater than or equal to 0. This confirms that the property includes equality when x equals 0. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.